The main parts which I am going to explain today are cylinder block, cylinder head, piston, connecting rod, crankcase, spark plug, injector, valves, manifold, flywheel, camshaft and crankshaft. Let us start with the first component, that is cylinder block. It is a container fitted with piston where the fuel is burnt and power is produced. It is one of the most important part of engine in which the piston moves to and fro in order to develop power. Thus the main function of cylinder is to guide the piston. Cylinder block always remain in direct contact with the product of combustion and so it must be cooled. For cooling of cylinder, either water jacket or fins are situated at the outer side of cylinder. At the upper end of cylinder, cylinder head and at the bottom end, crankcase is bolted. Generally, the engine cylinder has to withstand a high pressure and temperature. Thus, the material for an engine cylinder should be such that it can retain sufficient strength at such a high pressure and temperature. For ordinary engines, the cylinder is made of ordinary cast iron, but for heavy-duty engines, it is made of steel alloy or aluminum alloy. Sometimes a liner or sleeve is inserted into the cylinder which can be replaced when worn out. As we can see in this figure, this is known as the cylinder liner. As the material required for liner is comparatively small, it can be made of alloy cast iron, having long life and sufficient resistance to rapid wear and tear to the fast moving. Manufacturing of cylinder block can be done by casting, forging, and after that heat treatment and machining. Our next component is cylinder head. The top end of the cylinder is closed by means of removable cylinder head. There are two holes or ports at the cylinder head, one for intake of fuel and other for exhaust. Both the intake and exhaust port are closed by the two valves known as inlet and exhaust valve. The inlet valve, exhaust valve, spark plug and injector, they are all bolted on the cylinder head. The main function of the cylinder head is to seal the cylinder block and not to permit entry and exit of gases on covered head valve engine. Cylinder head is usually made by cast iron or aluminum. The cylinder head is usually cast as one piece and bolted to one end of the cylinder. Generally, the cylinder block and cylinder head are made from the same material. A copper or asbestos gasket is provided between the engine cylinder and cylinder head to make it airtight joint. The next component is piston. It is considered as the heart of an IC engine, whose main function is to transmit the force exerted by the burning of charge to the connecting rod. A piston is fitted to each cylinder as a face to receive gas pressure and transmit the thrust to the connecting rod. It is the prime mover in the engine. The other function of piston is to give tight seal to the cylinder to bore and slide freely inside the cylinder. Piston should be light and sufficiently strong to handle the gas pressure generated by combustion of fuel. So the piston is made by aluminum alloy and sometimes it is made by cast iron. Because light alloy pistons expand more than cast iron, so they need more clearance to the bore. Our next component is piston ring. A piston must be a fairly loose fit in the cylinder so it can move freely inside the cylinder. If the piston is too tight fit, it would expand as it got hot and might stick tight in the cylinder. And if it is too loose, it would leak the vapor pressure. To provide a good sealing fit and less friction wear between the piston and cylinder, pistons are equipped with piston ring. They are circular rings which seals the gap made between the piston and the cylinder. The piston rings are housed in circumferential grooves provided on the side of piston. These rings are split at one end so they can expand or slip over the end of piston. A small stroke engine has two piston rings to provide good sealing, but in a 4-stroke engine has an extra ring which is known as oil ring. The function of the upper ring, also known as compression ring, is to provide airtight seal to prevent leakage of the burnt gases into the lower portion. Similarly, the function of the lower two rings, also known as oil rings, is to provide efficient seal to prevent leakage of the oil into the engine cylinder. Piston rings are made of cast iron of fine grain and high elastic material, which is not affected by the working heat. Sometimes it is made by alloy spring steel. Port casting technique is used to manufacture piston ring. Next is connecting rod. A connecting rod connects the piston to crankshaft and transmits the motion and thrust of piston to crankshaft. It converts the reciprocating motion of the piston into rotary motion of crankshaft. There are two ends of connecting rod. One is known as big end and other as small end. Big end is connected to the crankshaft and the small end is connected to the piston by use of piston pin. Special care is required for the design and manufacturing of connecting rod, as it is subjected to alternatively compressive and tensile stresses as well as bending stresses. The connecting rods are made of nickel, chrome and chrome vanadium steels. For small engines, the material may be aluminum. Connecting rods are manufactured by using forging technique and after that heat treatment. Next is crankshaft. It is considered as the backbone of an I.C engine whose function is to convert the reciprocating motion of the piston into rotary motion with the help of connecting rod. This shaft contains one or more eccentric portion called cranks. The crankshaft of an I.C engine receives the effort or thrust supplied by piston to the connecting rod and converts the reciprocating motion of piston into rotary motion of crankshaft. The crankshaft mounts in bearing so it can rotate freely. As you can see in this figure, the shape and size of crankshaft depends on the number and arrangement of cylinder. It is usually made by steel forging, but some makers use special type of cast iron such as paroidal, graphitic or nickel alloy castings, which are cheaper to produce and have good service life. Next is engine bearings. Everywhere there is rotary action in the engine, bearings are used to support the moving parts. Crankshaft is supported by bearing. The connecting rod big end is attached to the crank pin on the crank of the crankshaft by the bearing. A piston pin at the connecting rod small end is used to attach the rod to the piston also rides in the bearing. The main function of bearing is to reduce friction between those moving parts. The typical bearing half is made of steel or bronze, to which a lining of relatively soft bearing material is applied. Next is crankcase. The main body of the engine to which the cylinders are attached and which contains the crankshaft and crankshaft bearing is called crankcase. It serves as a lubricating system too, and sometimes it is called oil sump. All the oil for lubrication is placed in it. Our next component is valve. To control the inlet and exhaust of internal combustion engine, valves are used. The number of valves in an engine depends on the number of cylinders. Two valves are used for each cylinder, one for inlet of air fuel mixture inside the cylinder and another for exhaust of combustion gases. The valves are fitted in the port at the cylinder head by use of strong pin or strong spring. This spring keeps them closed. Both valves usually opens inwards. Valves are usually made up of phosphorus, bronze and monol metal. Next component is spark plug. It is used in SI engine, that is spark ignition engine. The main function of a spark plug is to create a spark inside the combustion chamber to ignite the air fuel mixture. It is fitted on cylinder head. The spark plug consists of a metal cell having two electrodes which are insulated from each other with an air gap. When high potential current is supplied to spark plug, the current jumps from the supply electrode and creates the necessary spark. Next is injector. They are usually used in compressed ignition, that is CI engine. It sprays the fuel into combustion chamber at the end of compression stroke. It is fitted on cylinder head. Next is manifold. The main function of manifold is to supply the air-fuel mixture and collects the exhaust gases equally from all cylinders. In an internally combustion engine, two manifolds are used, one for intake and other for exhaust. They are usually made by aluminum alloy. Now next is camshaft. Camshaft is used in internal combustion engine to control the opening and closing of valves at proper timing. For proper engine output, inlet valves should open at the end of exhaust stroke and close at the end of intake stroke. So to regulate its timing, a cam is used which is oval in shape, and it exerts a pressure on the valve to open and release to close. It is driven by the timing belt, which is driven by crankshaft. It is placed either at the top or at the bottom of cylinder. Now next is flywheel. It is a big wheel mounted on a crankshaft whose function is to maintain its speed fairly constant. It is done by storing excess energy during the power stroke, which is returned during other stroke. Now take a look at this video and try to recognize all the parts which we have studied so far. This video basically shows the assembly of the parts of IC engine. And that's it for today's class. Thank you very much for being with me till the end. I hope you all liked this lecture and would have gained some basic information regarding the different parts of an IC engine. In my next lecture, I am going to explain about the difference between SI and CI engine and 4-stroke and 2-stroke engines. Please hit the like and subscribe button below and stay connected for the future classes. Bye bye, see you all again in my next lecture. Thank you.